All right, so today what we're going to be talking about is how to get going on Milestone 2. And you're also going to get, not today, today is mostly about WD1, but the lecture on Wednesday will also be on graphics and how to use them. So you're going to have a few, and the tutorial next week will be continuing this one about more things you can do in Milestone 2. So you have a couple lectures and a couple tutorials on this. Okay, so how do you get started on Milestone 2? So download the Milestone 2 handout, read it. How many people have read the Milestone 2 handout? Okay, so one person, good. So go read it. There's a walkthrough in section 4 that says, okay, how do you get going? You have to type ECE 297 and init2, for example, because we're going to put some extra code inside of your Git repo. So go through that walkthrough, it gets you set up. You're using a graphics API that we wrote called EasyGL. It's pretty easy to use. Read its quick start guide. Okay, so you can't use a graphics library if you don't actually read any of its documentation. So you have to read at least the first part of the quick start guide, which is about how to use EasyGL. EasyGL is a layer written on top of a more full-featured graphics library called GTK. You do not have to use anything in GTK directly if you don't want to. Okay, so you can, but GTK is huge. EasyGL is a lot easier to use, and you can make a good map just by using EasyGL, which is this kind of layer on top of GTK. Okay, after you've read that, you're going to modify your main.cpp. So in Milestone 1, everything was about the unit tests. In Milestone 2, your TA is going to grade your main program. You're actually going to demonstrate it for him or her. He or she is going to run it on their own and see how it works. And they're going to be running the actual mapper program, which starts in your main.cpp. Now, you're not going to have much code in main.cpp, just a little bit to kind of get things going. Most of your drawing code is still going to be inside libstreet map source, like in your library. And the top level routine there is going to be called draw map. It's going to have all sorts of helper functions. So this function will get, do not try to write everything in draw map, okay? Because you'll wind up with a 1,000-line long function and a TA who is just super sad, okay? So draw map is the top level routine. It should call helper functions for everything. And you're going to write those helper functions.
So if you're recording, the screen is not shared.
Oh, okay. Sorry about that. Thanks, Andrew. Okay, let me share the screen. Okay. Okay, so to begin with, you're going to make a few modifications to your main.cpp file, because again, we're running your mapper in Milestone 2, not just the unit tests. So in your main.cpp file, there's a main function. Does anybody know what this stuff is? This int argc and character ** argv. What is that? Yeah. Yeah, so this is how C and C+ programs get command line arguments. Argc is basically how many words the person typed on the command line. And this character ** argv is an array of C-style characters, C strings, that is each word. So you can use this if you wish to let the person type not just mapper, but maybe mapper Toronto or mapper Beijing, and use that word that they type or several words they type as an option to your program. So if you want to, you can parse these command line arguments, and that might be how you figure out the name of a map. It's not the only way to figure out the name of a map. You could have a button in your GUI where the person enters a map or something else, but it is one way you could have the person enter the name of a map if you wish. Yeah. Sorry, can you say it again? Yeah, pretty much. Your main is just going to do this load map and draw map, okay? So we do also make unit tests for Milestone 2. They're really there primarily to help you debug. They just run a whole bunch of maps, a whole bunch of cities through your program, so you can quickly see, do I show this city properly? Do I show that city properly? Those unit tests expect you to load a map, so call load map, then call draw map. Well, what they do is they call load map, then draw map, then close map. So you really should follow this convention of you load a map, then you call draw map, then you call close map. Okay, if you do that, the unit tests will work. And we also use them to run Valgrind on your program. So the main thing your TA is going to be looking at is your main program. But to make the unit tests work, follow this convention of load map, draw map, close map. Otherwise, you can pretty much do anything you want. Okay, so no. Okay, so changes to our main.cpp were pretty simple. Most of our code is going to be in libstreetmap in our library. So our first goal is just get the graphics up. Get a window that doesn't show anything, but just get it going. And so you're using a graphics API called EasyGL. And it's pretty easy to use. And it's going to make these buttons for you. It's going to make this title for you. And it's going to make these buttons for you. You are going to draw your graphics in this area, which is called the main canvas. But for now, we're not going to draw anything there. So it's just going to be blank like this. Okay? So we just want to get this window going. Whoops. Okay, so what do we do for this? So we're going to include m2.h, which gives the prototype of draw map. So there's not much in m2.h, and we wrote it for you, but it says draw map is a function that doesn't take any arguments. Okay, there we go. And you're gonna use that. And you're going to include a couple of header files that let you use the graphics library. So EasyGL application and EasyGL graphics. These are heavily commented. So to understand how to use EasyGL, you first read the quick start guide. And like at least the first 7 or so pages or 6 pages, which is like the basics of how to use it. There's some more advanced stuff at the end that you could skip if you don't want to use more advanced things. But you have to read that first 6 or 7 pages, and then you read these header files. They're heavily commented because they say, here are all the functions you could call. So you're going to go back to that many times. Okay, next we need our draw map to set up the graphics window. And the first thing we do is we're creating an object that is it's in the EasyGL namespace. So it's just like the STD namespace. EasyGL also puts all of its code in a namespace so that it's kind of given a nice clear name, doesn't pollute your other names in your program. Inside that EasyGL namespace, there is a class called application. And inside that, there's a type called settings. Okay, so I've just asked for, give me that type. And I want an object of that type. And I'm just going to call it settings. And then I'm going to set some variables. I'm going to set some of the member variables of settings. So settings, one of the things in it is, what is the name of what's called a UI resource? This is basically a file that says, how are the windows laid out? Like just, yeah, what's the graphics layout? We've created one for you, so just use this name. It's going to, when you do ECE 297 and init2, this is going to be put inside of your repo. So you already have this, just use it. I'm going to show you next tutorial how you can modify it if you want. So if you don't like the layout of the windows, you can change them, but you don't have to. You can just leave them alone too. Okay, another couple of things that EasyGL needs to know is, what is the name of the overall graphics window? What's the most important window? What is it called? So it's called main window in this resource that we gave you. And what's the name of the area where you're going to draw your graphics? And in the resource that we gave you, it's called main canvas. So, my strong recommendation is just leave all this alone. Okay, we set it up for you. It all works. Just copy it. You can change it all, but if you start changing it, you got to make sure you change it in ways that make sense. Then we basically create an EasyGL application object. I'm just going to call it application. And the constructor takes this settings object. Okay, so I've now created my EasyGL application. That still won't make the window appear. To make the graphics window appear, I need this line. Okay, so EasyGL application, call the member function run. And it actually takes 4 parameters. We're not going to use any of these parameters right now. We can set them all to null. So to set them all to null pointer. And this function is going to run for a long time. It won't return until the end user presses the proceed button. So this is going to basically capture mouse clicks and interaction with the user. Okay, so it's a bit different than most of the functions you've written before, that it doesn't just do something and immediately return. This will run for a long time until the person hits proceed. Okay. Okay, so after running it, this is what you're going to get. You're going to get, we didn't draw anything, so there's nothing interesting in the main canvas drawing area, but we do get this name, we do get these buttons, because EasyGL sets those up for us. So let me go show you that. Let's see. Let me quickly show you this code. Whoops. All right, so I just built the code. Okay, so this is what I'm running right now. So my draw map to function is just a little control function that I wrote so I can have helpers that do things. And it's calling this, which is exactly what I just showed you. So we're calling it draw map minimal. It just sets up the EasyGL application. And then it says, okay, run the graphics. So if I run this, let's see what it looks like. So it's exactly what I said, right? We get a graphics window. It's not very interesting, right? It doesn't do anything. Okay, so to stop that, but I was successful in bringing up the application. And this is the way you want to develop. You want to basically develop a little bit of functionality and immediately test it. So don't try to do too much at once. Okay, so we just saw that. Okay, now we want to make we're actually supposed to visualize a map. So that didn't look like Toronto. That was just a blank window. We need to do better than that. So we need to add a little more code in. So all of this code is the same. We're now adding in this in the middle. So we need to draw, we need to choose a coordinate system. So any good graphics package, well, maybe I shouldn't say good. You want to use a graphics package that lets you choose the coordinates. Because if you had to draw in pixel coordinates, it's inconvenient, right? You constantly have to think of, okay, I want to draw something here. Where is that on the screen? So what EasyGL does instead is you basically say what coordinate system you want, and it will handle all the transformation of what you draw into pixels. So it kind of provides a higher abstraction level that's easier to work with. So there's an object in the ECGL or class in the ECGL namespace called rectangle. So we're saying I want a rectangle. I'm going to call it initial world. And I'm going to initialize that rectangle to 2 points. The lower left point is 0, 0. And the upper right point is 1,000, 1,000. Okay, so I got a rectangle from 0, 0 to 1,000, 1,000. And then I make another call to this application called add canvas. So that's a member function in the EasyGL application. And it takes a few arguments, it takes 3. The first one is the name of the sub window that you're going to draw on. We already decided in this main.ui resource file that we created for you that would be called main canvas. So just call that main canvas. It also wants a coordinate system. So we just made this rectangle so that we could pass it in. So we're going to pass it in our coordinate system, which is 0, 0 to 1,000, 1,000. And then the last thing it wants is what's called a callback function to redraw these graphics. So we give it the name of a function that we write, which will be called anytime the graphics need to be redrawn. So the window's resized, the person zooms in, person zooms out, they pan left, whatever. This will get called in all those circumstances, and we have to write it. Okay, make sense? Okay, so the most interesting function, the most important function you're going to write for milestone 2 is your drawing callback. So who's heard of callback functions? Do you know that term? Guys who heard of what is a callback function? Yeah, so it's a good description. So as you get into more advanced programs, so far your programs, you've always, you call a function when you want something to happen. But there's another style of interaction where a framework like this graphics window, this EasyGL library, sometimes needs to call, it's taking control of your program. It's handling things like EasyGL's handling when a person zooms in or out, or the window's resized or obscured and it needs to be redrawn. There's lots of stuff it's handling, but it can't do it all itself. It doesn't know what you want to draw. So you have to, in the previous slide, you're basically what's called registering a callback. You're saying when something happens, when you need to redraw the screen, call this function. And now we need to write that function. You can call it anything you want. Okay, so I've called it draw main canvas, as long as you tell EasyGL what the name is. So I told it it's called draw main canvas, so I better write it with the name draw main canvas. EasyGL doesn't care what this does. It only cares how to call it. Okay, so it must return void, and it must take one input parameter, which is an EasyGL renderer. So this is another object in EasyGL. And in fact, you passed a pointer to it, okay? So the renderer is what allows you to get at the drawing functions. And you're going to be passed it, it's going to be passed into your redraw function. Okay, so don't change, the function signature. You have to have this signature for your drawing callback, but the name can be anything you want. Okay, so far, and right now we're going to have a pretty simple drawing callback, okay? We're going to have just draw a rectangle. Okay, draw a rectangle. If you look in the EasyGL headers in graphics.hpp, it has a whole bunch of drawing functions. One of them is called draw rectangle. It draws the outline of a rectangle, so it doesn't fill it in, and it goes from a lower left corner to an upper right. So this says draw a rectangle from x equals 0, y equals 0 to x equals 1,000, y equals 1,000, and just draw the outline. Okay? Does it make sense? So it's not a super exciting drawing callback, but we do something now. We will draw. Okay, so this doesn't actually show up very well on the screen, but it is trying to, I'll draw it on here. It draws a box like this. And well, we ask for the coordinate system to go from 0, 0 to 1,000, 1,000. You'll actually see when I do a demo that, I didn't draw that very well. It actually goes all the way to the top and bottom, but doesn't go all the way to the left and right. Even though I said the coordinate system is from 0, 0 to 1,000, 1,000, and I said draw a rectangle from 0, 0 to 1,000, 1,000. Why do you think it doesn't go all the way to the left and right? Any ideas? Maybe it's not obvious, so I'll tell you if it's not clear. What do you think? Since you have an idea. Yeah, that's exactly right. So the window's not square. So what EasyGL does is it doesn't want to distort your coordinate system. Okay, so it wants a unit in the x direction to be the same distance on the screen as a unit in the y direction. So if the aspect ratio of what you ask for doesn't match the screen, you just get a bit of extra real estate. Okay, which is better than having distortion. But that's why it doesn't go quite to the corner, to the left or right corner, because the window's not square and you ask for a square coordinate system. Okay, so let me go and demo that. Okay, let's see. Okay, so the way I'm going to demo that. So actually, let me first do this. Okay, I'm going to comment that out, comment that out. Okay, so I'm first just going to draw this rectangle in my callback. So I'm calling it draw main canvas blank. I'm going to draw this rectangle from 0, 0 to 1,000, 1,000. I haven't actually said what color. I haven't said what line width. So it's just going to use the default. And the default line width is pretty thin, like 1 pixel wide, and the default color is kind of a gray. So let's go down and take a look at this. Oops. Okay, so this is my overall control routine. I'm just going to comment out my first helper function and bring in the new one. So all this new helper function, draw map blank canvas, is just doing what I showed you before. Okay, so it sets up the application, it sets up the coordinate system, it adds in this canvas so we can redraw, and it sets what the callback is. And this is the callback. Okay, so it's all been kind of hooked up by that routine. And then when we call application, I'll go back again. When we call application.run, it's again going to stay in this application.run routine for a long time. You know, all the panning and zooming and interaction we do, it's all going to be handled by this. When it needs a redraw, it's going to call this draw main canvas blank function, because that's what we said for it to call. Okay, so let's run this. Okay, so doesn't look, on my screen, I can see a faint rectangle, well, a faint square drawn, but I don't think you can, right? It's too faint, doesn't show up on the screen. So I'm going to hit proceed, which basically gets out of that. I'm going to go here. All right, and I'm going to basically change the color to black. And your IDE knows these function calls. So this is another way you can see the functions. So I just did G dash, and you can see a bunch of different EasyGL. I can draw an arc, I can draw an elliptic arc, draw a line, draw a rectangle, etc. These are all outlines. I can draw text. And I can do fill arc, fill polygon, fill rectangle. Those all draw filled in shapes, and so on, okay? I can also draw surfaces. Surfaces are basically like bitmaps, images that you've loaded in from PNG. And I can also figure out how much of my coordinate system is on the screen. So I don't expect you to remember all that, but basically, this is what I mean by you read the header file to see what's available, and command completion or subroutine completion in the IDE is also helpful to you, because you can basically use it to just kind of see what are my options, like what are, and all of the comments show up as you're going through these as well. Okay, so let me get rid of that. Okay, so I basically changed, this is red, green, blue. So I've said set the color to black. Red, green, and blue are all 0. Set the line width to 10 units, okay, instead of 1 unit. And well, 10 pixels instead of 1 pixel. And this now should show much more boldly. Okay, so, and there's my new map. And you can now clearly see the rectangle, right? So it shows up. And as I said, it doesn't go all the way to the corners because the window's not square. I can click on these buttons, like zoom out, and my callback's not changing. You just saw my callback. It's really simple. It just always draws a rectangle from 0, 0 to 1,000, 1,000. But when I click on, you know, go left, etc., I didn't bring a mouse, but if I had a mouse, I could also just use the mouse wheel to zoom in and out, and I can drag to move things left and right. It goes zoom fit. It goes back to kind of filling the screen. So what's happening? How is this happening? My callback is not doing anything. It's all, well, my callback's always doing the same thing. It's always drawing from 0, 0 to 1,000, 1,000. So why is it drawing differently on the screen? There's no particular reason you would know how this works, but maybe you can guess. So what do you think's happening? Okay, so yeah, you might not be able to guess this one. So this is part of what makes EasyGL easier to program in. It's handling what's called a transformation matrix for you. So you ask for a certain coordinate system, and now you can draw on your own coordinate system. As a person zooms in and zooms out and so on, EasyGL is keeping track of how does it transform objects in your coordinate system to pixels, okay? And it changes that transformation matrix as the end user zooming in and out and panning and so on. So you can always draw the same thing and it'll show up on screen correctly. This is a good way to, again, build sort of abstraction into your layers of graphics. It's much easier for you to do that And now the graphics library worries about all the transformations. Does that make sense? Okay, so if I hit proceed, I'm going to leave that application.run. So now I'm done. And let's see, let me go back to the slides. Okay, so we successfully have drawn, we've got a window up. Now we've managed to draw a rectangle. Let's see if we can draw something that looks like a city. Okay, so we're going to draw intersections because they're relatively easy to draw. And first, I'm going to basically set up some data. I'd like to make my redraw functions fast, so I'm going to set up some data so they have less work to do when they're, because when the redraws can be called a lot. If there's anything I can pre-compute kind of in my load map, I prefer to do that, okay, to make my redraws faster. So, so I've declared a structure here. So the structure has got a latitude and a longitude called position, and it's got a name that's a string. So I'm going to call that my intersection data. And I'm going to make that global. So I make a vector of intersection data, call it intersections. And in my draw map, I'm going to basically, it's probably better still to do in my load map, but I'll just show it to you in draw map here. My intersections is, I call resize on. And remember, intersections resize, that will basically create intersections entries in that vector. Okay, so after this line of code, I have an initial set of data with nothing very interesting in it, but I've created data for every single intersection in my vector. And then I'm going to load it up. Okay, and you probably don't remember how to load this up exactly, but I can just loop through all my intersections. So from 0 to get num intersections, and I can ask Streets Database API, what's the position of that intersection? I'm going to store that. And I can ask, what's the name of that intersection? I'm going to store that. Okay, so my loading code is pretty simple. It's so simple, you might say, well, maybe I don't even need this, right? Why have that? I could just call Streets Database all the time in my redraw function. Then you could choose us to do that. I put it in a variable to see if I can make it as fast as I possibly can, and maybe I have to make things a little more complicated later. Okay, after I've got this setup going, then I call this application.run to pass control to the graphics. And I need to make my redraw function actually use my data. Okay, so I just set up some data, but I'm not doing anything with it yet. So here's my redraw function, my draw main canvas, still drawing that big rectangle. I want to use a function called fill rectangle. Okay, so in EasyGL, one of those functions that I quickly showed you in the IDE was called fill rectangle. It takes a lower left point, an upper right point, and it draws a rectangle filled in between them. So what do you think I should do? How am I going to draw all these intersections? So just tell me the rough outline of how you would draw all these intersections in the redraw function. You don't have to get it exactly right, because it's really hard to get things exactly right when you don't fully know the API and you don't have a computer. So that's too much to ask. Anyone want to take a shot at this? Just telling me, okay, what are you going to do? I can see you thinking about it. Go for it. Okay, so are you going to loop through all the intersections, or yeah, okay, so you're going to have a loop. You're going to go through all the intersections. We just loaded up this structure, well, this vector with intersection data. It's got intersection I.position. Is that right? So that gives me the position. You're going to call fill rectangle. What will you pass to fill rectangle? So yeah, so that sounds great. So that's exactly right. Okay, so we're just going to loop through all of the intersections. So that's what this is doing. I'm going to have a couple temporary variables because I find it makes it easier to read. So I'm going to make an X, which is my longitude, and a Y, which is my latitude. And that's not enough to draw fill a rectangle. I also need to get the other corner. I shouldn't put magic numbers in. So I'm going to declare there's a width. I'll set it equal to 10, and I'll say the height is the same. So this basically is going to draw a rectangle for every intersection. Its lower left is the latitude and longitude of the intersection, and its upper right is just shift that over by 10 units to the right and 10 units up. Yeah. Which one, like X and Y? Yeah, that's a good question. You could pull these out. So you're saying like you'd like to pull these out here? Probably safer. The compiler, when it optimizes for simple things like floats, and these are just, it'll figure out with very high probability that these are constants, and it'll just reduce this to 10 and stick it in there, no matter where you put this. Does that make sense? Same thing. These temporaries, the compiler will basically just optimize away. Yeah, for a simple variable like X and Y, this shouldn't matter, okay? You could try it. That's in release build. In debug build, you're right, the compiler doesn't do any real optimization, so it's probably slower than if you declared X, might be slower than if you declared X and Y out here. And the same thing for width and height. With optimization on, it shouldn't matter, okay? But I haven't actually tried this exact piece of code to see. Basically, compilers do a lot of optimization. So when you have simple variables like floats and constants, it usually doesn't really matter because they will do optimization and figure out that this X and Y are only used here. So they won't, I mean, they have to store this result somewhere and connect it there, and they'll just connect it as directly as they can either way. If this was something complicated, if you start getting a bunch of function calls in it, then it can matter, okay? Because it's harder for the compiler to, reason about your code and be sure that it can just get rid of a temporary value if there's a function call in the middle. Does that make sense? But yeah, it's a good question. Okay, so this is going to draw a rectangle for every single one of our intersections. So let's see what it does. So if we draw this, this is what we're going to get. And it's kind of hard to see. So let me go off and show it to you in a demo. Okay, let's see. All right. Okay, so I'm just going to comment out one helper function and use a new one. Okay, make this a bit bigger. Okay, so you can kind of faintly see the outline of, this is the box from 0, 0 to 1,000, 1,000. So you can hopefully faintly see that. Where does this look like Toronto? Doesn't look like much like Toronto. Yes, your TA will not be happy. Where are all my intersections? I did have a loop to go through all my intersections. Where are they? Yeah, where do you think they are? Yeah, that's exactly right. So, and I can't, so my intersections are here. Okay, that's Toronto. So let's go take a look at what happened. Oops, let's see. So yeah, those are all my intersections. Why? What happened here? Any idea? Yeah. Yeah. Yeah, so I'm just going to repeat that. So I didn't line up my coordinate system with what I'm actually drawing very well at all. So Toronto's latitude goes from about 43 degrees north to 44 degrees north. Okay, so it doesn't change very much at all. And I said I want my window to go from 0, 0 to 1,000, 1,000. So on that coordinate system, everything is basically in a small dot, right? So it didn't do a very good job of choosing a coordinate system. I just picked one at random. Okay, so what do I need to do to fix this? Like that's my fundamental problem is that, yeah, latitude and longitudes don't map very well to a coordinate system that's a 0, 0 to 1,000, 1,000. What should I do to fix this? What do you think? Use Cartesian coordinates. Okay, so you're saying don't draw latitude and longitude. Like, is that right? Like draw X and Y in like meters on the Earth. So that's exactly right. So, but you're solving two problems. So you're too good, right? You just solved my next two problems. So hold that thought. And that is what we want to go to. So for sure, that's right. What else? What do I need to do to just fix this problem? Let's say I still love latitude and longitude. Okay, so I'm a pretty bad teammate. I keep arguing, no, latitude and longitude is the way to go. Okay, so what can I do to fix this problem by itself? Basically, two ways it can go. I could say, well, I got to write some code that changes my latitudes and longitudes to be between 0, 0 and 1,000, 1,000, or I could change my coordinate system. What do you think I should do? Either one of those two things would work. I could say the coordinate system is 0, 0 to 1,000, 1,000. I need to make sure that for Toronto, I somehow scale the latitude and longitude so that my numbers go from 0 to 1,000. Or I could change my coordinate system. What do you think? Which of those sounds like a better approach? Sorry? You think you should scale it? Okay. Anybody else want to take the opposite view? What do you think? Yeah, so it's better, both can work, but it's better to change the coordinate system because basically EasyGL already has all that scaling logic in it. You're just not using it because you didn't tell it the actual coordinates that would be convenient. So I just picked 0, 0 to 1,000, 1,000 at random. And I could now write all sorts of scaling logic, but that's going to be more of a pain. So what I'm going to do instead is, so this is basically just talking about what we said. We're using a bad coordinate system for latitude and longitude. I can set a coordinate system that goes from my minimum latitude to my maximum latitude, from a minimum longitude to my maximum longitude, and that's going to fill the screen. And that's going to be relatively simple. EasyGL will just do all the scaling for me. So, Streets Database API does not give you a mixed minimum latitude and a maximum latitude and so on, but you can compute it. So I want it for intersections. So how can I do that? And this gives you a skeleton. Like, what am I doing? How am I figuring out the maximum latitude and the minimum latitude? Yeah. Yeah. No, you can't have functions and variables with the same name. Let me think about that. I mean, it's bad practice anyway. Okay, so it's a bad idea. What a function name really is it's a memory address. Like that's what C++ turns it into. It's a memory address that says go to this memory address and call the code there. Okay, so the name tells you what is the function, and that's how it gets hooked together for your program to work. It has to be able to unambiguously figure out what name are you talking about. So if you use that name for some other purpose, it's going to get confused. So now C++ has rules that if the inputs, like the inputs to a function are different, it can tell that that's a different function. I don't think it's going to like it if you give a variable and a function the same name, though. And in any case, even if it can figure that out, it's bad practice because you're going to confuse the reader of your program. Does that make sense? Best thing to do is type in a compiler. I think you'll just get an error message because they consider it so bizarre that they just don't want to allow it. So what I'm doing here is I'm going to go through all the intersections. I'm just going to work out the minimum latitude and maximum latitude and so on. And the code's not very hard. So I need to initialize all of these variables to something, and then I need to go through every single intersection, seeing how do I update them. So what can I set max lat to? There are a couple different choices that will work. What do you think? What do you think? Yeah, so I could set this to be the latitude of the first intersection, and then I can compare it to all the other ones and just take the maximum of what I've currently got versus all the other ones. So that's exactly what we've done here. Set the latitude and longitude to be those of the first intersection, and then go through all the intersections and just take the max and the min of the current intersection and what I had before. This is actually a little bit of, I'm actually doing the first intersection again. So technically I could start at 1. Okay, so I can make this very marginally faster. This is an order n calculation, right? I just went through all of my intersections. Is that a problem? What do you think? Do you think it's bad? It's order n? So you have to think about where am I calling this, right? So maybe it's a problem, maybe it's not. Depends how often I call it. What do you think? Yeah, so if I put this in load map, who cares? It's called once, order n is no big deal in load map at all. So this is perfectly fine, okay? Okay, anything else I need to do? Well, I basically take those values that I just calculated. I'm going to stick them probably in my global data structure. So calculate them in load map, keep them around, and I set my coordinate system to basically have those points defining it. Okay, and if I run that, this is actually what I'll get. So I get just a black screen. So what happened? It seems so promising. Any idea of what just went wrong? What do you think? Yeah, the intersections are really big. Okay, so if you remember, I was drawing fill rectangle from the latitude and longitude as the lower left point to 10 units to the right and 10 units up. Okay, so 10 lines of longitude is a lot. Okay, that's something over 1,000 kilometers. 10 lines of latitude is a lot, right? So 1,000 kilometers, much bigger than Toronto. So I just drew every intersection on Toronto on top of itself. So it does look like a big black mess. So it's way too big. So if we change that though, so I played around with it and found that 1,000th of a latitude or longitude is more reasonable. And now the intersections draw at a reasonable size. And we can draw that. And I don't change it on the zoom level, which means that my intersections as I zoom in will look bigger, which is reasonable. You might not like that, in which case there are calls in EasyGL to figure out how zoomed in you are. So if you wanted to, you could change the intersection size as you zoom in. But it's not unreasonable that as you zoom way in, things get bigger. So it's also fine to leave it alone. Okay, and you get something that looks like this. So let me quickly, whoops. Let me go to the demo again. All right, so I'm going to comment out that helper function and go on to the next one. Whoops, what happened there?
I think something is already running. Like there's a graphics window in there.
Wait a second. Let me see what I got here. Okay, sorry, I got the window gone already. Okay, let's do this again. Thanks, Andrew. Okay. Okay, so there's my city of Toronto now. Okay, and it kind of looks like Toronto. And I can zoom in and look at things, and you see my intersections get bigger because I didn't say they should be scaled at all. But yeah, this basically looks like Toronto now. Is there anything else I should do? Okay, so there's one last thing. Okay, so is this correct? And actually now your error is, so back there in the corner, you actually flagged this error before. You said we shouldn't be drawing latitude and longitude, okay? It distorts the map. So it might have been hard to tell, but that Toronto was too wide and not tall enough. Because the distance between lines of latitude is the same everywhere on Earth, but lines of longitude get closer and closer together as you get towards the poles. So you can't draw latitude and longitude. Some fraction of students who don't attend this tutorial will draw lines of latitude and longitude anyway. The TAs know to look for it. You know, it's on the rubric. Don't be one of those people. Don't draw latitude and longitude, okay? So what we have to do instead is exactly what was suggested a few minutes ago. We should convert to X and Y. And X and Y is the map projection that's described in milestone 1. You can get the location in meters on the surface of the Earth, assuming the Earth is locally flat, which is pretty good approximation for a city. So go look at the M1 handout. You're going to need the average latitude of a city. So you can pre-compute that just like you computed the min latitude and the max latitude. You're going to use that average latitude to find all the X, Y points you like, and you can draw them. Do not stick that all over your code. You want helper functions because you're going to use this a lot. So here's one way you could do it. X from longitude, Y from latitude. Or you might make, maybe you take a latitude longitude pair and you convert them both at once. Doesn't matter, but don't scatter the calculations all over the place. Make sure you have helper functions. This isn't as important, but you might find that you sometimes want the inverse. Go get a longitude from an X or a latitude from a Y. If you find that's useful, then you can write those functions too, but use helper functions. Okay, so with these helper functions, now you can start to see why did I make this intersections vector. I now have something a bit more interesting to store in it. Instead of just storing the longitude and latitude in it, I'm going to convert those to X and Y and store that. That's a good thing to do in my load map or at the very start of my draw map. Basically, doing it outside of my redraw routine is smart because you want your redraw routine to be as fast as possible because it affects how responsive your map is. Okay, so if you can pre-compute it, okay, rather than doing it. You will sometimes be called with a redraw, several times a second if people are like dragging things around. So you'd rather not repeat this calculation for every single intersection several times a second. You'd rather put it inside of your load map or at the very start of your draw map. Okay, so I've converted my latitude and longitude to my X and Y. I'm going to choose, I need to choose a width and height that matches that. So now this is in meters. It's actually easier for me to think about what does my coordinate system mean? It's actually distances in meters. So I'll say I'm going to draw an intersection that's 100 meters wide and 100 meters tall. And I'm going to fill a rectangle wherever I have an intersection. Anything else I need to change? Okay, so I've pre-computed my intersection locations in X and Y, stored them. I've changed my callback function to draw using those new X's and Y's. This is my setup code, right, where I'm going to launch my graphics window. Anything I need to change here? So what do you think? There's one thing I need to change on this slide. So this coordinate system is still latitude and longitude. Okay, if I do that, nothing's going to show up. So I need to make sure that whatever coordinate system I choose, it's my choice, but whatever I choose here in this initial world has to match my drawing functions. So I need to change that. So I just need to convert these latitude and longitudes, min and maxes, into X and Y min and maxes. And again, my helper function, this is why you write helper functions. This is now really easy to do with my helper. Okay, and if I do that, it's kind of faint, sorry. Toronto looks more correct, right? So it's the right height and width. If you compare the projections, I'll change the colors of this later, sorry about that, but this one looks more like Toronto, this looks too squished, right? And I'll do one last demo and then we're done for today. So let me show that to you. Whoops. Clicked X too many times. Let's try that again. Okay, and now it looks basically like Toronto. Okay, and again, I can zoom in, zoom out, move around, and I didn't write any of that code myself. Now, just because I was showing you intersections because it's relatively easy to draw. That doesn't mean you should draw intersections as your representation of Toronto. Probably it's going to look nicer if you draw streets rather than intersections. So you might choose to draw intersections. You might not choose to draw them. You want to draw parks, buildings, streets for sure. You may decide you don't really want to draw intersections that looks ugly. But the techniques are basically the same. Okay. So that's it for today. Thanks, everybody. Sorry, I think I went a few minutes over time. So I'll be up here in case you have any questions.